Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks.
Hi everyone. Welcome to this amazing live mock DSA interview session where we conduct live sessions with our candidates, and very happy to see you all here and taking part in these sessions that we are conducting. So let me introduce myself first. My name is Suniti and I am a mentor here at Geeks4Geeks, and today we are having with us our next interviewee. So let's just get started. And yeah, I will just add him to the stream. Hi, Suraj.
Hello, ma'am.
Hi, how are you doing?
Ma'am, can you repeat? Like your voice is cracking.
Yeah, like how are you doing? Like, how's everything going?
Very nice, ma'am.
All right, that's great to know. So, can you please just introduce yourself?
Hello, everyone. Hello, ma'am. Myself, Suraj Patel, pursuing BTech from Guru Ghasidas Vishwavidyalaya in Computer Science Department. Okay, actually, I'm final year student. Past 1.5 year, I am doing competitive programming. I'm a 5-star coder on CodeStep. I'm expert on code forces, and I'm a guardian at Pro. Okay, and in this summer, I have interned at Zero Lab in software field.
That's great, Suraj. That's quite an impressive profile that you have. So let's get started. I will quickly just inform you what we are going to do is a doc link has been shared with you, right?
Mhm.
So I will be giving you the questions in that doc link, and then you can start with explaining your approach. And then once we are done on that part, then we will move on to the coding part, wherein I will share you the link for the Geeks for Geeks practice portal. All right.
All
So
right, ma'am.
let's get started. I will just help you with the first question of our session, and that is. Okay, before that, can you please share your screen?
I have said, ma'am.
Okay. I think the screen is not visible. Are you sure on that part that your screen is okay? Just a second. Yeah. All right. And you can open that. All right. So the question is given an array of size n, find the next greater element for each element in the array. All right. Let me give you our first test case. Just say will be 3, 4, 4, minus 1. Okay. So yeah, this is our question. An array is given to you and the size of the array is n. you need to find
Mhm.
the next greater element for each element in the array. All right. Say for example, the first element is 1. So the next greater element to 1 is 3. All right. And our next element is 3. The next greater element 2 is 4. Right. Similarly, it goes for
Right.
2. And for 4, as we are not having any next greater element to it, so that's why we are printing 1. Okay. So,
Okay, ma'am.
yeah, that is the problem statement that we have here. So, you can start with your approach.
Uh, what I can do from here, I can run a loop for each element, and for every particular element, I'll be running another loop. Inside a loop, I'll be running another loop. If I'm getting, like, let's suppose for this example, test case of 1, 3, 2, and 4. Okay. First, I will be iterating every element for I will be checking for 1, then 3, then 2, and then 4. Then after that, I'll be running loop for 1. From index of 1, I'll be going further. If let's suppose I'm going 3, here I'm getting 3 greater than 1. So for 1, the answer will be 3. And for 3, I'll be running loop uh, next to the 2. I'll be going on 2, then next to the 4. Here I'm getting 4, which is greater than 3. For 3, I will be matching 3 to 4. Then for 2, I'll be running loop. From 4, I'll be getting a 4. So here answer is 4. And for 4, I'm getting nothing. So for 4, answer will be minus 1. For this, for this approach, my time complexity would be very high. It is the order of n square. So for the optimization purpose, I can use a stack. I can say monotonic stack. That a stack contains it is a data structure that contains increasing order of the element. I can say. Uh, so using a stack, I can do this in O of one time complexity. So I'll be iterating from the backward. So for this example, 1, 3, 2, and 4. For this, I will be maintaining one stack. So initially my stack is empty, and then I'll be iterating 4. For the 4, my stack is empty. So the answer will be minus 1 for that. Like there is a 4 space. For 4, answer will be minus 1. Then in my stack, I'll be pushing 4. Then my stack contain 4. Okay. So next, for 2, I will be checking top of the stack. If I'll be iterating, I'll be checking if the top of the stack having less than of my current element, then I will be popping the element. If I'm getting the element just greater than my current element, I'll be like considering the answer for that particular element. So here the top of the element is 4. So for 2, my answer will be 2. And the next, my stack contain 4 and 2. Then I will be coming to 3, and I will be checking the top of the stack. So my stack contain 2. So I will popping 2 because 2 is the smaller than 3. So now again I will be checking 4, the top of the element, top of the stack, which is 4 and which is also greater than 3. So for 3, the answer will be also 4. And for and again I will be pushing in a stack 3. So my current stack is 4 and 3. And then 1 for 1, I will be checking top of the stack, that is 3, and also greater than 1. So for 3 for 1, answer will be 3. This is the my approach.
Okay. So, what will be the time complexity of the approach and space
Uh,
complexity as well?
hmm. The time complexity of this approach will be order of n, and a space complexity as well will be order of n.
All right. Okay. Your approach seems fine to me. And I will just share the question link to you. Just a second. Yes. I've shared the link. You can go ahead and then you can type your code inside the portal.
So should I start with optimized one, or first I have to
You can
go
start
through?
with the optimized.
Okay. So first I will be checking. I will be taking. There is one answer vector. Then I will be taking one empty stack. Then I will be iterating my array from the backyard. Then so here, first I will be checking if my stock stack should not be empty. Then also I am checking my top of stack if less than or equal to my current element, that is ARRI, I will be popping. So if I'm checking if that stack is not empty, this means I got the just greater element to the my current element. So answer of my ith element would be st of top, and then I would be pushing my current element to the stack, and then at last I'll be returning my answer. I'm again explaining. Here I am taking answer vector, then I am taking one stack, okay, and then I am checking for the every current element. First I am checking if what if my stack is empty or not. If the stack is not empty, then I'm comparing the top element and my current element. If the top element is less than or equal to the current element, it means this is not greater than current element. So I am popping that top of the element. Then again I am checking if the stack is not empty, it means the top of the stack element is greater than my current element. So I will be assigning answer of I equal to top element, assigning to the answer of I. Then I am pushing current element into the stack, and then at last I am returning the answer. So should I have to submit?
Yeah, you have to submit it. Great, Suraj. That was a really nice attempt by you. Like you solved it just in the first go without any kind of hint required, help required. So yeah, that was great. So okay, we are good to move to our next question. All right,
All right,
and
ma'am.
yeah, the next question that we have here is that okay, yeah. So I will just write it down. So what we have is given two things presenting arrival and departure time of the train platforms. Find out the minimum number of platforms required so that all the trains can board. Okay, we'll just help you with the test case. Okay, so let see the size is given is 6. Okay, we have two arrays here, that is arrival array and departure array. All right, so what we have here is that arrival time of trains are given and departure time of the trains are given. Okay, so what you need to do is you need to print out that how many platforms are required. All right, so all of the trains can arrive and depart from the particular railway station. Cool. So here, as you can see, the order of our arrival and departure time is arriving at 9 and departing at departuring at 9:10. All right. So for this, we will be requiring one platform. And then next is starting from 9:40 12. As in this case, we will not require any new platform, right? We can use our one platform that was already there. So that's why answer remains one. But here we may require another platform when the arriving time is 9:50, right? So that's why the count is incremented to 2. And in
Mhm.
this next case as well, we will be requiring a new platform for the arriving time of 11, and thus the count has been incremented to 3. So that is what we have our answer. Okay, so
Okay.
yeah, that is the question. So you can is the question statement and test cases clear to you?
Yeah, that is clear. My first approach would be of n square. What I'm doing first, okay, one doubt is there.
Yeah.
Like arrival time is sorted order, like always in the sorted order.
No, 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 none of the arrays are in sorted order.
Okay. So what I will be doing, I'll be okay. First, I'm telling my brute force approach. So brute force
Okay.
approach would be I need to. I think I need to sort the array. So I'll be sorting the array according to the arrival time, and then by brute force I'll be checking for the every platform. So what I mean, so let's suppose I am taking the first train. Okay, then reaching to the, like, I'm assuming there is no platform initially, so there is one platform. Okay, and the train one is
Okay.
reaching. So train one.
All right. So the first thing that you have done is you are sorting your arrival array, right?
Yeah, yeah. Uh, Arrival array. Okay, I'm trying to tell brute force. Then I'll be telling optimize approach.
Okay, this is brute force. All right.
Should I have to go with optimize approach
No, you
directly?
can start with brute force approach. No, you can start
Okay.
with brute force.
So what I'm doing, actually, I'm like I'll be making pair of departure time and arrival time, and then I'll be sorting my array, like vector pair of array. Okay. So I can assume like so what I tell you, you understood, na?
Yes, exactly. Like in brute force approach, you are sorting the array.
Sorting the array. I'll be making like what I'm doing. Let me do this here. So I'm like arrival of I and departure of I. I'm making pair and sorted correspondingly uh, according to the arrival time. Okay. And let's suppose
Yes.
the train reached the platform one, and directly then I'll be checking. So what I'm checking, just greater like 9, 10, just greater than this. Which one is the just greater? So 940 is the just greater. So what I can do, I can assign to the train to platform one, and then
Like how
after,
are you? It's just greater thing.
no, I am checking which train arrival time is greater than departure time of previous train, just last train which is reached initially. Okay. So when I'm going like 12, like I'm coming here 950 is greater than departure time of train 2. So for this I need
Okay.
one more platform. Okay, I will be writing train 3. So for 1100 I need one more platform because departure time of train 2 and train 3 is greater than arrival time of train 4. So I need one platform for that. Okay. And for 1500, like 1200 is less than 1500. So for I can assign platform 1 to train 5. And for train 5, I can assign platform 2 or platform 3.
All right. So 3 will be the
So
answer.
T6. Wait. So this is my brute force approach because I'll be checking every, like when I am at ith element, I'll be checking every train to the right of the element. So I'll be checking, like I'll be running two loops inside the loop. This is the O of n square things.
All right. So like if you are already running two loops, then what help did this sorting thing did to you?
No, sorting thing. What I confirm inside my mind, like I'm taking the train which reach the first, like which arrival time the first.
Okay, so for that you use the sorting thing.
Mhm.
Okay. All right, like, okay, let me just share the link. You can, just execute this brute force approach as well, right? Just a
Okay.
second.
I'm telling optimized approach as well, and simultaneously I'll be writing both of the code.
Okay, all right, go ahead.
Okay. So for my optimized approach, I'll be sorting arrival array as well and departure array as well. And then I'll be taking as what I how can say. Uh, Let me explain. Let me check one time. This is 940, 950, 1100, 1500, 1800. So 9, 10, 11, 20, 1130, 1200, 1900, and 2000. Okay. So by this, I can surely say that this departure time is less than all of this, and this arrival time is less than this. So I will be only considering if my this departure time is greater than this one. So what I'm doing here, like this, okay, let me write on for you. My current, like initially my platform should be needed. My answer would be 1, and my current departure time would be 9:10. Like at 9:10, my station is, I can say, uh, at 9:10, there is a train. There is no vacant, I can say. When I will be reaching 9:40, so my departure time would be updated to 11:20, because an answer will be not increases, because this arrival time is greater than this uh, this mm, this departure time. Then again I will be coming here to, so I can see, I can wait.
Maybe you can, all right, I just want you to try. So, like,
Mhm.
maybe after a minute or two, I shall give you a little bit of hint. But before that, I just want you to try. Because I
Okay,
guess you
okay,
can
sure.
reach to the approach. Your logic is quite good.
Then I'm thinking like, is it working or not? Like I'm confused.
All right. Okay.
So till one, here is platform required only one. So when I am reaching the train two, so the departure time of previous train is greater than the arrival time. So I need one more platform. So I'll be adding one more platform. Okay, and I'll be updating my departure time to 11:30. So when I'm going to train number 3, and my current max departure time is, so I need to, so what I need to track the minimum departure time of 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 current element. So here the platform is only one. There are two platform I have assigned. One departure time is 11:20, and one departure time is 11:30. So there are two platform. One departure time is 11:30, and one departure time is 11:30 and 11:20. So when I reach to platform train number 5, so there is the arrival time is Wait, where I'm okay, I'm at train number 4. So when I will be at train number 4, the both of the platform is not empty. So I have to make one more platform. Okay, and I have to, and the departure time of that train is 19. Okay, and when I'll be reached here, so I need not to make another platform because here is my lowest platform. Okay, so here will be I am platform number assigned to 1100. Okay, okay, I got the logic. So I can explain the logic again. So for this, I think I need a priority queue for that. So by that, I can make sure, like I can get by priority queue which platform has a minimum departure time. So
Okay, and how
okay,
is that going to help you?
huh, okay, I'm explaining again. So let's suppose I assign platform. Let me erase this off. Hmm, okay, so I am at platform number 1. Uh, so and that is only there is only one train with the departure time 9:10. So if
Okay.
the train having arrival time less than 9:10, that would be not able to reach that platform number 1. If a train having arrival time greater than 9:10, I can assign the train to the platform number 1. Okay. So when I am going at train 2, I can check the platform number 1 have departure time less than arrival time. So what can I do? I can assign train number 2 to platform 1. Okay. And that platform number 1 uh, would be empty at 11:20. So when I'll be coming to train number 3, so its arrival time is less than 11:20. So for
Yes.
that, I need one more platform, platform number 2. So for that, and the at the time of 12, at time of 12, the platform number 2 would be empty. Okay. And no, 12,
No, we were on the third. Yeah.
11:30. 30.
Yeah.
When I am going at platform number 4, so I am checking platform number 1 is also not empty and platform number 2 is not empty. So I need to take one more platform. Okay. And at what time platform 3 would be empty? At 12 o'clock. And when I am going 15 o'clock, I can check. So I can assign any of them. So I'll be assigning here. So,
How
and
are you doing this checking thing?
checking thing, I'm keeping the priority queue. I'll be getting minimum departure time. So minimum departure time, let's suppose I'm making the priority queue, minimum of 3 is 11:20. So
Yeah.
if 11:20 is, I can say, greater than 1500, so every other element is also going to greater than 1500.
Okay. Why can you say that? That if 1120 is greater than 1500, then why every element will be greater than 1500?
I am keeping the mean heap, no? Mean heap. The top of the mean heap is always giving the minimum element.
All right. So let us say if the place that where you have written 1200, it could have been 1600, right?
Okay.
And yet
It could
the yeah, but in that case as well, 1120 would be the minimum element, and 1120 is greater than 1500. So this platform you will have empty, but you can't conclude this, right? That all the elements are greater than
Can,
1500.
can you repeat again? Let's suppose
Like
you were telling, let's suppose
let us
1200
say
is 1500.
it is 1600, yeah.
Okay, this
So
is
in that
1600.
case, yeah, so in that case you can't conclude that if 1120 is less than 1500, that all the elements will be less than 1600.
No. What I'm telling, na, what I'm telling, I need only one platform required for the only one train. What I'm telling, if let's suppose there is 1700, if 1700 is like top of the my priority queue is greater than 1500, so all the element in the priority queue is greater will be greater than 1500. That is I'm telling.
Okay, all right. Okay, fair.
So for this, I will be assigning platform number 1, and departure time will be like at the time of 19. And for similarly for this, 11:30 is minimum. So I'll be assigning this. So the answer will be 3 for this. Is there any error?
Error does not seem, but okay. Are you confident with this approach, with this priority
I,
queue thing? You think that you really need a priority queue? I mean, you are just keeping track of the minimum departure time that we have and the maximum departure time that we have till that point, right?
uh,
These are the only two things that we care about: the minimum departure time and the maximum departure time. So, do you think
wait,
you will be needing priority queue?
because I have sorted already.
Yeah,
Wait,
priority queue does nothing other than the sorting.
wait. I have sorted already. So maybe I need not require priority queue, but with the help of priority queue, I can solve surely.
Okay, let us. You have already explained two approaches, so that's quite fair. Let us just move ahead with that. All right. So, okay, I will just share the link. Yeah, maybe you can get the intuition while you are solving. So you can start.
Yeah, yeah. So first time
All
sort the
right. Can
arrival
you
time.
tell me, uh, while we use this sorting keyword, can you exactly tell me what sorting algorithm is implemented internally?
Internally, uh,
Yeah.
wait. Uh, I think there are two algorithms. Mutually, they work together. One is quicksort, and another one is there are two algorithms. I know one is quicksort, essentially I can say, and
One is what?
one is let me memorize. I cannot memorize right now. Okay, I am telling in between when I memorize.
All right. Okay, just go ahead with the question. We will discuss that later.
Okay. So first I'm solving with the help of priority queue. Then I will be optimizing my the solution.
All right. All right.
So my current answer will be one, and my so there is I'm making priority queue. So I'll be taking PQ dot push. Okay. So then I'll be going through one, two, and then what I'll be checking if my current arrival time is greater than or equal to. So one also think if arrival time and departure, let what I'm telling. If a station vacant at 10 and simultaneously if a departure time of another train is 10, so can I assign the train to
No,
that platform?
you will need a new platform for that.
Oh, okay. For that I'm checking if my arrival time is greater than my top of the priority queue. Nothing to do with greater than. If less than. Less than or equal to. So I'll be again answer plus then I'll be. So what you need to do? I need to pop that element because I have to assign one more element. So and I have to pq dot push. Here I'm assigning new element now. So departure I else pq dot pop and pq dot push. What I'm doing here. So if my top of the priority queue is greater than. It means of the no platform arrival time, departure time is less than my current arrival time. Then what I am doing, I will be taking one more platform, and then I'll be marking his like that particular platform departure time. And if there any platform exists that I can assign, so what I'll be doing, I'll be popping the current platform departure time, and then I'll be assigning new departure time. Similarly for this here.
Yeah, oh, got it.
Here.
So
So
maybe rather than writing that PQ dot push two times, maybe you can write that one time,
hmm,
outside different else loop.
yeah, yeah, yeah. So I think this should work. Yeah, this should work. One thing I have to do, I have to remove this priority queue. How can I remove this? Hmm. So how can I remove this? Okay, okay, which I understood into what, how can I do? So I did not to give this. Hmm. Hmm. I need not to take anything. So what I can do, I can take one pointer. Hmm. So what I'll be doing if my hello,
Yes, you're audible. Are you
hello.
saying something? Yes, I can hear you. Can you hear me? I don't know if problem is from my side. Okay, guys, am I audible? Can I just...
Okay.
Yeah, okay, thanks
Hello.
everyone. Yeah, all right. I guess we are good now.
So wait. Departure day.
Thanks everyone for the confirmation. Yeah.
So wait. So what I have done here, let me. So what I've done here. So I have already sort the departure array and arrival array. So what
Okay.
I'm doing, if I'm checking my current departure trend, so I know like my departure array will be sorted in sorted order. So I'm standing at platform number J, I can say. So if my departure of J is greater than, so it does mean कि I need one more platform.
Yeah, fair.
So if my departure time is greater than, so I'll be not to uh, required another platform. So I can explain from here. I'll be taking here example. So I'm erasing all this. I'll be taking. So first I'm assigning platform number one to my train one. Okay, and this departure time is 9:10. So I know here is train one. So then I will be going at train number two. So if I'm going at train number two, I can see that departure time of like train number one is less than train number two. So what I have to do, I have to assign platform number one to train number two, and again I have to increase my counter j from 0 to 1, because I cannot compare train number 1 departure time to other, because the last train that is reaching to platform number 1 is train number 2. So I can only compare of arrival
Mm.
departure time of train number 2 only. Okay. So
Yeah,
I'll
that's
be
valid.
increasing the count. I will be increasing the counter here. Okay. So again, and if I am going at train number 3, so I am here looking for that departure time of train number 2 is greater than arrival time of train number 3. So what I have done, I assign one more platform to train number 3. So and currently I am standing it
Okay.
here.
Again, you're checking. You're just checking for departure time. Departure time was
Yeah.
greater than train number two. So
No,
why are you
not.
checking for
No,
departure
wait,
time?
wait.
Like,
So, so I am writing here everything. So initially I have answer equal to 0 and j equal to 0. So what is j? J is tracking the minimal departure time. Like what I can say, the platform having minimum empty time. A platform at that time would be empty. Okay, the minimum departure
okay,
time
J
of train.
is keeping track of the minimum departure time that we have.
Yeah, yeah.
Okay.
What I can say, ki at that time, at least one platform will be empty. So
Okay,
how
if
I
J
can
is
say that?
keeping track. Okay,
J
go
is
ahead.
keeping. huh. So I'm returning. So currently I am taking already. So okay. So platform number one is already train one is there. Okay. So what I am at train number two. So currently I am j equal to 0. So I can see my departure time is less than my arrival time. So again I will be assigning 2, and again I have to uh, my increase the counter, because I have assigned platform number 1 to platform train number 2. So my departure minimum departure time would be 11:20. Okay. So when I'm going here, I can see the arrival time is less than my current departure time. So I have to make another platform too. Okay, and I need not to increase the j, because uh, this is already less, and I am assigning new platform. So my current arrival time and departure time should not be changed.
Okay.
So when I'm going at train number 4, I can see that my current departure time is greater. So again, I have to make one more platform. When I am going to at train number 5, I am seeing my current departure time is less. So I need not to increase the counter, rather than I have to increase the my j I have to
Yeah.
increase. What how why I am increasing j? Because this departure time is already taken by this train. So that
Yeah.
platform number 1 would be empty at this time. So the minimum departure time of any platform would be 11:30. Okay,
Yeah,
so when I
fair.
am going at train number 6, I will be not increasing the answer because my current departure time is already less rather than I am increasing the jth value.
Yes. All right. Okay, yeah, that seems fair. So, can you just go to the portal? You have already submitted this new code, right?
Yeah,
Or
that's
are you
something.
yet to do that?
No, no, I am again submitting again.
Okay, this. Yeah. Yeah, great. This seems fine. Okay. So now the time complexity for this code is.
Here I am applying sorting things. So the time complexity would be, I can say, O of and log n.
Okay, so coming back to the sorting algorithm. So, which sorting algorithm are we using for this sort?
So I know by manually I can sort the array. Optimized sorting algorithm is merge sort. And for this, I think one is quick sort and one more algorithm is there. They mutually work together. But right now I cannot memorize that.
Okay, no issues. Actually, there are three sorting algorithms that work together, and collectively they are known as intro sort. All right. So that is actually a combination of quick sort, heap sort, and insertion sort.
Yeah, yeah.
Okay,
Okay, thank you.
that is
Thank
the thing
you.
that we are using. All right, and the space complexity here, you haven't used priority queue. Okay.
This is space complexity would be O of 1.
Yeah. So, all right. That was great. So yeah, that was okay. Just a second. We have okay. So yeah, that was all about today's session. Those two questions that we had. Now let us come back to the feedback part. Okay. So yeah, on the basis of the session, how much would you rate yourself?
I think it should be 9, but in last question I fumble a little bit. That's why 8 would be nice for me.
No, actually, it was a 10. But just because in the last test case, you just kind of took some time, but that is not really a matter of concern. So, yet again, it is a 10. But just let us keep it 9.5, right? Because, just you do some things because you were not knowing that what is the sorting algorithm behind the keyword. See, we use sort so frequently, like that is the most common thing that we use in all the questions that we solve. So we must be aware of the fact that what is actually running behind the screen, okay, how it is getting implemented. So for the first question, it was great, like you just come to the optimized approach from the brute force approach very directly. So 10 on 10 for that. And for the next question, yet it took you some time, but you were able to get to the approach. Like logic was very much clear in your mind. You were very much aware of what you are doing, what is the demand of the question, right? You were very much aware with that. So yeah, 10 on 10 for the next question as well. Point 0.5 deducted because you didn't know what is the sorting algorithm. All right. So that was a great session. You performed really great. All right. It was a really great interacting with you, and your enthusiasm, your communication skills, your confidence, your coding skills, everything is 10 on 10. Okay. So keep up the good work. And yeah, anything from your side?
So nothing much I want to ask. Just I am want to ask. So in terms of my communication skill, how much you will rate myself in communication skill? Like how I am communicating, I am able to explain the all the things properly, or I am missing something.
No, you were not missing something. Okay, see, there was one point while you were solving a question. You said that, okay, first of all, I will just solve in my mind and then I will be explaining to you. So that one thing was there, but that is not an issue. Your communication skills are good. You were able to explain what you are doing, right? You explained all the test cases, right? For all the three approaches in the second question, you did three approaches, and for all the three approaches, you explained using the test cases. So your communication skills are pretty well. There is no any problem on that part.
Okay, thank you so much.
All right. Yeah, and here we have people as well who are who are complimenting you that you were extremely good and you performed really very well. So Yeah, that was very impressive.
I need to perform well because I'm doing competitive programming from 1.5 years. If
All
I'm not
right.
able to solve these
Anything else
questions,
from your side?
no, I think it's enough.
Yeah, that's nice. Okay, so keep on practicing, keep up the hard work, and we wish you all the best. Thank you for
Okay, thank
joining
you.
us.
Thank you so much.
All right, guys. So we had Suraj with us, and as all of us see, he performed really very well. He was able to solve all the questions, and he did all of it in a very limited time frame. His communication skills were good. His problem solving skills were good, and his logic part was good as well. He was able to get to the most optimized approach. So that was very good thing. So all in all, it was a very good session, very impressive session. So, any feedback, anything from your side, do let us know in the chat section. And we would love to see you all as well in our upcoming sessions. So, do not forget to fill up the Google Doc. The link has been provided in the description section. So, do fill out that form, and we will be having you in our next interview session. And yeah, that's all for today. Anything, any feedback, any suggestions? You all can add that in the comment section, and we would be seeing it. And thanks for all the compliments. All right, guys. So that's it for today. See you all very soon. Till then, keep up the hard work. Bye, everyone.